My name is Kevin Andrea, and I'm an instructor in the Department of Computer Science right here at Mason Engineering. My field, I believe, is the most exciting area of computer science, and that is in systems programming. Every semester, I have the distinct honor to be able to join with students from all over the world so I can work with you, taking your knowledge of all of these application programming and tear down the abstractions so that we can get more out of our computer. In systems programming, we learn to directly access the operating system, as well as all the techniques we can use to access the hardware itself. Now, this is one of the most beautiful fields because we can see exactly how our computers work, and we can use that knowledge to the benefit of everyone else. It's like being able to listen to the anthem that the computers are singing, and we could add our own voice to it to complement everything that's already happening. It makes our jobs that much more effective. Now, when I was an undergraduate, I had no idea about any of this. It wasn't until my senior year when I got involved in a robotics laboratory that I was able to see how easy it was to put code directly on hardware. In fact, it wasn't the fact that I could program a robot, just a collection of different boards to drive around and pick up soda cans. The most mind-blowing aspect of this was that I could program arbitrary hardware. I wasn't limited to laptops and desktops anymore. I could now take a custom device and directly put my code onto it. This is like driving the Enterprise straight through a wormhole into a dimension where all of these possibilities are now limitless. And right here at Mason Engineering, in our CS grad program, we start off with a course to introduce this field. CS 531 is our introductory systems programming course where we learn about how to directly access the hardware through techniques that are applicable across all the different areas. We learn about the API to access the operating system. In fact, when I teach that course, I always start off with an exercise right from day one. Last time I taught it, in fact, I had my students design a high-level algorithm to convert a sentence of English text into Morse code. Now, on its own, that's exciting. That's a good program. But instead of just tapping some things out on a screen, with just one small additional step, we could take that implementation and put it directly on a microcontroller that doesn't even have an operating system. This is what we programmed during that first day of school. And now we've turned a simple algorithmic exercise into something I could put in a box and sell as a Morse code trainer. This is the most beautiful aspect of this field of computer science. We are where the code meets the hardware. And that gives us the possibilities to do anything that we want. Now, my own doctoral research in computer science was all about the Internet of Things. It's like devices that I can speak aloud and have it tell me the weather. We can have devices all across both our homes, industries, at work, in the fields, reporting information to give us more productivity at work. In fact, my apartment right here is filled with small devices like this. This is a wireless sensor network. It's part of the Internet of Things. And my research was on looking at how we can more optimally have these devices autonomously create routes with each other to be able to send information back to a base station, even though they don't know anything about this environment. In fact, the push of one button here on this unit will activate all of these devices via wireless, and now they will automatically route to be able to create a network to send data, in this case temperature and humidity, back to my computer. So now I can do something about that. And of course, this is a simple example. We use this in industry. On manufacturing lines, devices such as these are being deployed to be able to give fine tuning to the controllers so that they can produce better products. In our follow-on courses, we go into distributed systems, parallel programming, networking. We look at cryptography and security. And all of this is based on the state-of-the-art research by experts who are publishing and defining that state-of-the-art in research. So I know this may seem really overwhelming. Always, whenever you are getting into a big decision, look back on everything you've accomplished. Now, in your undergraduate, you may not have felt it at the time because we were pulling you along to get to that next level faster than you were ready. But if you look back, you will see that you have already accomplished so much, and you are ready for this jump into the future because you have already risen to the challenges that we have given you in the past. You will be working with experts, and you will have the opportunity to engage in research that is state of the art in industrial settings, security, cryptography, looking at the general Internet of Things, smart homes, smart everything. Systems programming is nothing short of understanding the computers themselves. So make sure to find something you enjoy and pursue it. Explore all of the programs out there and look at all the facets that we have in our programs here at Mason Engineering. Because when you take that next step, this is going to be a new journey for you. And it is going to be something that is always going to be exciting. Just remember to think of us, because we would be honored if you would join us to either continue your education or to come back into school so that you can start that next chapter. But now, if you'll excuse me, I have some Jedi to find.